Hello everybody. In this lecture, I am going to show you how to calculate the moment of inertia of a solid sphere. Calculating moment of inertia of solid sphere is somewhat easy when compared with this spherical shell, because the results which we got in spherical shell, I am going to use it here. Same result I will use here. Okay, assume that this is a sphere of radius r and mass m. Okay, now what is the difference between shell and sphere? Shell means inside it is hollow, there is no material, but for a solid sphere there is matter even inside the inside surface of this shell. Okay, so to measure it, what I will do is I will consider a small annular strip of, let me call it as radius x. I will consider a sphere of or shell of radius x, spherical shell. Inside this sphere, I will consider this spherical shell of, let me call it as radius x, and this thickness I am taking it as dx. This is spherical shell. I don't know its mass, I am taking it as dm. Okay, now from our previous observation, what is the moment of inertia of this spherical shell of radius x? For a shell, moment of inertia di, because that shell I am considering here as a elemental mass. Okay, di is equal to mass of this shell I am taking as dm into, what is the expression for moment of inertia of spherical shell? 2/3 m, that is dm into, here the radius is x, because of which I am writing it as x. This is the moment of inertia of this small shell of radius x, which is concentric with this solid sphere. So what is dm here? Because it is three-dimensional object, am I right? Dm. To find out dm, what I will do, I will define one parameter known as density. Rho is equal to dm divided by dv, which is nothing but m divided by v. That implies dm is equal to, what I can write? Dm is equal to rho dv. Rho into, what is the volume corresponding to this small strip? Surface area, that is 4 pi x square into thickness of this strip I considered is dx. Now I will substitute back into this expression. Therefore di is equal to moment of inertia of this elemental shell is given by dm is how much? Rho into 4 pi into x square dx into 2/3 into x square. That implies di is equal to, what I can write here? Rho is constant, 4 pi is constant, 2/3 also constant. 2/3 rho into 4 pi into x square, x power 4 dx. So if you wanted to calculate total moment of inertia, therefore total moment of inertia of this sphere is given by I is equal to summation over, the value of x should change from 0 to, by the time it reaches outer edge, it should be r. 0 to r. 2/3, 2 for the 8, 8 pi rho divided by 3 into x power 4 dx. That is equal to, here 8 pi rho 3, everything is constant, pull it outside the integration, 8 pi rho divided by 3 into summation over x power 4 dx, where this x changes from 0 to r. That is equal to 8 rho pi divided by 3 into x power 4 dx is x power 5 divided by 5, but the limit 0 to r. This integration you will be getting 8 pi divided by 3 into, what is rho? Rho is density, mass by volume, m divided by, what is the volume of the total sphere? 4/3 pi r cube into, if you substitute upper limit, lower limit, anyhow it will be 0, r power 5 divided by 5. That is equal to, this 3, 4 to the 8, so all these things cancel, r cube r power 5 gets cancelled, you will be left over with, okay, 2/5 m into r square. This is the expression for moment of inertia of solid sphere. With respect to which axis? Simple, because it is symmetry axis, no? Whether you take this as z axis or x axis, y axis, anything, everything is passing through the center of mass, center, because of which whether it is Iz or Ix or Iy, whatever you call it as, this is Ig only. That is axis passing through its center of mass. So till now we calculated moment of inertia of ring, disc, shell and sphere. I would like to summarize all these things because these observations are very useful while calculating time taken by the body to roll down the inclined plane. There I am going to use these observations, because of which I would like to summarize all these things over here. Okay, so first thing is I calculated the moment of inertia of circular ring. If you take this as a circular ring, okay, with respect to an axis passing through its center of mass and perpendicular to the plane containing this ring. Okay, this I am calling it as Ig, mass m and radius r. So Ig is equal to, for circular ring, what I got, m into r square. M into r square. Okay, so same thing, by using this I calculated moment of inertia of disc. This is for ring. Next for disc, so perpendicular to the plane only, Ig is equal to, how much I got it is m r square divided by 2. Next I calculated for shell, spherical shell of radius r and mass m passing through its center of mass. So any axis passing through center is center of mass only for shell, because it is symmetric. Ig, mass m and radius r. Okay, Ig is equal to, what I got, 2 by 3 m into r square. By using this idea, proceeding like this, I calculated for sphere, solid sphere. Solid sphere, how much I got it, Ig is equal to 2 by 5 m r square. Here you need to observe one thing. For same mass and radius, out of all these 4 configurations, which one has larger moment of inertia? Check it. This is 2 by 3, this is 2 by 5. Is it looking like 3 or 5? This is 2 by 5 only. This is 2 by 5, this is 2 by 3, this is 3. Out of all these 4 configurations for same mass and radius, this ring has got more moment of inertia. You keep it in mind. So this is the overall thing regarding moment of inertia of ring, disc, shell and sphere.